My name's Dana. I work with Paula up in the IHR. I'm one of the research biostatisticians up there. Work closely with Matt to help students, supervise students, do some work with some of the hospital clinicians as well. If you're not in a health-related field specifically, I apologise for some of the examples here are very health-focused, but the principles are still the same. Okay? So we're just looking at entry in Excel because that's what most people have access to. Most statisticians don't like Excel because it's too easy to make mistakes in it. But the programs available for data entry are often quite expensive to buy and require you to learn another skill, another set of information on how to use particular programs. So we recommend you use Excel, but with these guidelines, because it helps us to minimise data entry error, which is a bigger problem than you think, specifically, particularly if you're doing a lot in one go. Minimises the risk of misinterpretation. Often our data sets are actually being shared with other collaborators, so we want to make sure that everyone is on the same page. It will also minimise the amount of data manipulation required. So has anyone actually tried to read in data into a stats package and had to play around with it and then spent 7 or 8 hours trying to work out why the dates don't do what you want them to do? This is what we're trying to not have about, okay? So these are the skills I hope you at least have an understanding of by the end of lunchtime. You structure your Excel spreadsheet. We have to choose appropriate variable names, variable labels, value codes, and other labels, and we'll see what they are in a minute. Construct a code book or data dictionary that goes to making sure people are all interpreting things the same way. A little bit of formatting Excel cells. We're only going to cover a couple of ideas here using ranges and prepare a drop-down menu. Once you've had a go at it, there are a whole heap of other options there, and you may be able to use those for your specific case to try and make sure that people can't make mistakes. And probably what the most important thing is to know what not to put in your spreadsheet, because it's the things that can be there that usually cause problems for the stats packages. Okay? So you're going to set up your spreadsheet. Has anyone heard of wide and long format before? No? No? Okay, so wide format is what you typically see. You've got your rows represent the cases down the side, and along the top we have columns representing variables. But if you have a look at a couple of those variables there, I've got a T1HR, T1BP, T2HR, T2BP, time 1, time 2, heart rate and blood pressure. You can see they're going across. So one person has a variable value that is a mixture of both what's being measured and the time in this case. And if you contrast that to a long format, we've only got 2 variables here. We've got heart rate and we've got blood pressure. And the time is coded in the B column there. You can see that time 1, 2, 1, 2, 1, 2. That's called a long format. Both ways, you have to make sure that you can uniquely identify each line. Over in the wide format, the ID is enough to uniquely identify someone. You know, ID 1, you can find pressure at time 1 or at time 2. Whereas in the long format, if you want to uniquely identify time 2 blood pressure, you need to know both the ID and the time column, okay? Don't have to worry too much about it. What we recommend is that most people is you enter in wide format. That seems to be the way that most of us think. The problem is that if you are doing kind of repeated measures, you're going to need to restructure that into long format so that SPSS or Stata will actually be able to use the data for the sorts of analysis you're going to do. You can do that in the stats package, provided you keep all the variable names constant. Okay? So if you're more comfortable with wide format, it's probably better that way, keep your variable names constant and then get some help with restructuring in a package because it's more traceable. And really what we're trying to do here is make sure we don't make too many errors. Okay? Now there's a few guidelines for variable names. First of all, most important, it only takes the first row in your Excel spreadsheet. If you start splitting your variable names across more than one row, the stats package gets confused because it will only read the first row as names and everything else is considered data points. So if you've got a text variable, like a word, in your second row down, you read it into SPSS or Stata, it gets very confused and says, oh, everything must be text. So all your numbers become text and then the computer can't do any calculations with them. And that's a major problem we see quite often. Why isn't it working? Your variable names aren't all in one row. Keep them short if you can and keep them meaningful. You know, B, C, D, E, F doesn't actually mean anything unless that's the way you label your questions, for example. You've got to make sure you know what they are. Short just makes everything a lot easier, particularly if you use a command-driven analysis package. You need to contain all relevant information in the variable name. These are fairly obvious things, but when you come to doing it, it's not always thought of. Have no spaces between the words, that's just stylistic. SPSS, I think, it won't let you read it in, whereas Stata will go and jam all the words together, so just leave it out. You can only start with a letter or an underscore, don't start anything with a number. For some reason it won't accept that either. And they have to be consistently named, and by that you can see my little example here. I've got heart rate 1, heart rate 2, not HR1 and HRAT 2. Okay, that's because if you need to restructure anything, the program is going to take the first section of the label, or of the variable name, sorry, and the number. And if the first section is different, it won't know that that's heart rate, You can't tell the same way we can. We can take in lots of different information and based on context know, oh, that's heart rate. But the computer only knows what you give it. Okay, it's not very good at taking things in context. And you will save yourself a lot of heartache if you do have to restructure at any stage. Now, when you set up your spreadsheet, you've got your variable names. If you've got categorical variables, it's worth having variable codes. So there are two ways of doing it. I personally prefer to use codes if I was entering data, zeros, ones, twos, threes, because it needs to be numeric in the end anyway, and I can label it later. If you do use female, male, for example, rather than 0 or 1, you can read that into the stats package, but it may not work until you recode it. So that's another step you have to do in your stats package. So it's just a little bit extra time. And if you've got 100 variables, that's quite a lot of recoding. Okay. I also like to use 99 for missing data, because usually there is a category called 99, and that way I know when I see it that is a missing data point. I may set it to missing in the stats package later on, but it means that I know it's been checked for missing. If it's just missing, I don't know whether that's just not actually being entered by accident or if it's not there. And then I will query it if I'm doing analysis for someone. I go, you've got these missing points, are they supposed to be missing? But if they've told me 99 means missing data, I can go, yep, good, cool, I accept that. Continuous variables. So do you know what I mean by categorical and continuous variables? That's all. Yep, cool. I like to use a code for those as well. That's probably more a stylistic thing. Again, that way I know it's truly missing, but you have to be careful what code you use. 99 may not be a good missing code if it was for diastolic blood pressure, for example, because it could be a true value. You wouldn't be able to tell the difference. And again, it's easy to do when you're sitting there for hours on end putting numbers in. So you really do need to make sure it's not in a true value range for the variable. The other thing to make sure you do for continuous variables that are numbers, don't put text in, don't put NA or missing, not recorded, because the stats package will then read that whole variable as a string or as text. Can't do any computations on it. You'll have to pull out all those text words and recode it to a number anyway. Okay, so try and use numbers. The other thing I recommend is if you have missing dates, this is the only time I recommend leaving it blank. Because if you start putting codes in there, it will read that as if it were a date, and you'll start to have, people being tested on the 6th of January 1960. It reads it as the wrong date because of the way the internal recording of that particular date. So I like to leave those ones blank. Sorry. Free text variables. Has anyone here got any questionnaire type work where you've open-ended questions or caveats on responses? Well, the main thing to remember there is that the number of variables required for each question depends on the number of answers given. So if we said list 3 breeds of dog you consider as a pet, you would need breed 1 column, breed 2 column, breed 3 column, and then write them or type them in. If you put all the dogs that were listed into one column, it's hard to sort them out later. It's hard to actually work out what percentage of people said X, Y, Z. You'll have to separate them out anyway, so you may as well start like that. It also makes it easier to see because one word in a column is better than 3, 4, 5, 6 words, because sometimes you'll have a question like, how, list all the breeds you consider, and someone could write 15 breeds and you end up with something that's just not interpretable to you, let alone to the other. And the other thing with free text answers is make sure you put them in exactly as they appear on the survey or questionnaire that you've used, so that whatever your source information is must match what's on your database. Okay? It's good practice. You may make changes later, but you won't make changes to that variable. You'll create your own. Date variables, we've touched on this briefly, and I think we all agree that's the 14th of May 2009, which is the birth date of my first daughter. You might read that as 14th of May 2009, you'll think it's all different, you get all confused. If you're using Excel, if you use that format and type straight in, it will automatically set it to that format, and that reads in beautifully to Stata and to SPSS. You don't have to worry about it. If you do need to check formats, you all probably have used that in Excel. I think it's coming up in a minute. I would always use that format. It just saves so much time, and always use the four-digit year, because as we're getting further into the next century, there are sometimes if you're looking at birth dates, for example, 2020 and 1920 could be both be reasonable dates. If you need to check what your format is, if you right-click the cell that you want to enter your data in, go down to Format Cells, and then choose Date, and the top type seems to work fine. Okay? That's just to reduce your headache a bit when you read it in. Now, we were talking about using codes, but particularly if you have different people working on your project, there might be different sites. There might be data entry going on at both sites, or 20 different sites. You want to make sure you're all using the same codes. It's not been unheard of to find that the same project, different groups using different codes, and everything has to be redone before you can actually do any analysis on it. So let's start from the beginning, doing all the same things, save you a lot of time. This is a code book that I set up for a spreadsheet. I put it in a spreadsheet, another sheet in Excel, so it's on the next page in Excel. It's got the variable and a description. Notice I've also put in the measurement units, which probably not too much of an issue in some cases, and others would be very important. Make sure we're all entering in the same units. I have the codes listed and the labels for those codes. I've got -9 missing in this case for heart rate and blood pressure, because there's no way you could have a minus heart rate or blood pressure, and 0 and 1 for male and female. And I can use this to help set up a drop-down list in my cells, which limits data enterers, to only the values I want them to be able to use. Okay. So if we go up the top to data along the top of the Excel sheet, and then you want to click on data validation, you come up with this window, and under allow there's many options. I've chosen list in this case because I'm going to use the gender list with the codes. So I've chosen list. If you click on this little box here, source, it takes you to the Excel spreadsheet, and then you can highlight the cells you want to use. So 0, 1 and -99 for gender. Click on there, sorry, they're the cells, and we click on again that little box. We'll go back to that window, and it tells us where our codes are. And now I'd like to put an error in. So I go over to the top where there is an error alert, and I've written in the error message, be 0, female, 1, male, 99 missing, to remind people that's what they should be entering, just in case. Probably not too much an issue for gender, because there's not all that many options, but some of the more complex variables where you may have 15 different options, it would be worth doing this for sure. And you will find that people get confused and sometimes start thinking that you think 0 is male and they think that 0 is female. Not a good thing. So you get a drop-down box where you go to enter something in once you've set it up. And I tried 6 and it gave me my error message. Okay, so it's just a way to reduce those errors that do happen. The next option you could use is using under allow a whole number. And here I've said data can be between 100 and 200. Perhaps that's some sort of physiological that I was interested in. It just stops those accidental typos where a 0 is being left off or 3 zeros have accidentally been added. And then if you read it into your data set and you find an error, read it into SPSS or to data, you find an error, you look at something and go, oh, you know, 3,000, it shouldn't be 100. What do you do? What would you do with an outlier like that?
Go back to the original result.
Yeah, exactly. Don't just delete it.
Yeah.
So the less errors you have, the less work you're going to have rechecking. There, a surprising number of people just go, oh, that's an outlier, delete. Not good practice. There are some.
That's in just from your course perspective. Apparently, in the secondary school curriculum, they actually teach the students to relate to standard deviations away as an outlier. And it's in the curriculum. So
You're joking.
No, because I raised it. I run that session I do with schools, and it's known because it's in the curriculum, and that's why they teach it at school, which is probably why students think that
it's good
way.
Yeah. I've noticed that now.
Yeah, they try and delete. Yeah,
and sometimes dismiss it as an outlier, therefore I'm not going to consider it as part of my analysis. And sometimes you sort of, that could be the interesting piece.
Yeah,
exactly.
Absolutely.
Exactly.
So I teach that in a research methods project in my 10s, and the teacher the last time, I can't believe it because we teach them not to do that, and she opened up the curriculum guide and said that's where it says to teach. So it's probably worth us noting for undergraduates that that's
hammer that home.
Yeah.
Because we get, I'm almost halfway through my master's in biostats, and the first thing we get told is you don't delete outliers, and here's the story behind why. So we up at the IHR, we reckon do not know, unless of course it is completely impossible and you've got evidence the machine malfunctioned on that day. Yes, that is an outlier. That's not reality, right? But otherwise, if it's there, it's there. If you don't have any reason to, any objective and independent reason to view it as being a true outlier, you've got to leave it there. Yeah. If it does play havoc with your stats, such is life, eh? If you're interested in using these data validation functions, there are a whole heap of YouTube articles, YouTube videos, articles through Excel where you can actually, particularly if you're doing a study with multi-sites, I do recommend you spend some time setting this up because it will mean you have a lot less to check at the end, and that will really slow things down. It'll take you a lot longer to get to where you want to go with your data. There's nothing more frustrating than having some data, wanting to see if it fits with your research question, and having to wait 3 weeks for someone to go and check 2 numbers. Okay? Particularly if you're trying to get your PhD in. Now, when it does actually come to entering your data, please take lots of breaks if you do enter in bulk, because we're all human and we fatigue. And the more you fatigue, the more likely you're going to make errors. We want to enter in real time if possible. I used to do some studies where we would have people come in for almost a day filling out a lot of questionnaires. We would enter in the data as we got it because invariably someone would miss them, and then the questionnaire title would no longer be valid. So if you have that opportunity, it's worth doing it as you go rather than waiting to the very end. You should end up with a lot less missing data. And use that data validation tool if you can, and the dictionary, the data dictionary, and make it really clear, and perhaps have a meeting about the data dictionary with all your collaborators to make sure everyone knows exactly what's going on.
Sorry, it's the data dictionary, this is the code form.
Yes, that's right. Yeah, sorry, I use the term interchangeably. Yep, exactly right. And as I said, I think this is probably the most important thing when it comes to making sure your data reads nicely into your chosen stats package is what not to include. So often people will have kept row means or column means because you're having a look at the data, see what you've got. That's fine. You just make sure you delete it before you read it across, because you end up with a situation where you've calculated a mean for the variable, but you've included the mean of that variable. And if no longer particularly relevant. So we need to make sure there's no summary stats in there. The stats packages can do all that for you. You don't need to have a mean column through Excel. It's also more easily traceable if you do it through a stats package. So you want to leave all of that analysis to after you've read it in. Empty and blank rows or columns aren't actually catastrophic, but when I see them, oh, what's happened there? Have I deleted something? It's just best to leave them out so you don't have any unnecessary queries coming up. Don't put text and numeric variables in the same values in the same variable. And we just mentioned that earlier. It gets the program confused, and it will read everything as a text variable. If you find you're trying to put numbers and words in the same variable, you probably need two. So you probably need the numeric column and then the one with the comments or queries or questions or caveats, whatever it happens to be for that particular question. Usually in survey questions, you'll find that you'll need that kind of setup. The thing we see quite often is colour coding. That's great if it helps you with your data entry and helps you make sure the right thing's going in the right places, but it doesn't actually tell the stats package anything about what the data means. It doesn't read colours, so it's not useful. You have to make sure that anything that is colour coded is also coded as a variable. And identifying information, this is probably a given, but you'd be surprised how many times people send us data with names and addresses in it. It's usually, or if not always, a requirement of your ethics approval to keep the data de-identified. You may need to be able to trace back, that's fine. If you have a spreadsheet that's password protected with your ID numbers and your names, and I never see that, or your data analyst never sees that, that's fine, you can trace them back. But anything you send through to anyone else has to be de-identified. Okay? I'll just say, it's got names in it, don't want it, could you please send it back, de-identified. And ethics really does require this. It's quite an important aspect of our work. All right, so if anyone's interested, I mocked up a spreadsheet that kind of looks pretty cool, but it has a lot of errors in it, and it won't read in well to your data analysis package. And if it does read in well, you'd have to do a lot of things to it before you could actually use it. Okay, so it's meant to be, made up data looking at two groups, one group that meditated and one that didn't, blood pressure, body temperature, and anxiety measures as our outcomes in this case, and measured twice, before they did anything and after the meditation or not. Is there anything you can see there that might cause problems?
Heaps.
Heaps, yeah, it's pretty bad. It's a really bad one. I tried to find everything.
I was going to say, it kind of communicates, but
yes,
what you're talking about,
it does.
It doesn't serve.
And that's the whole point, is that computers need absolute precision in everything you say or do. They can't interpret. We can interpret. And I think that's where people get mixed up with doing this sort of spreadsheet setup. They know what they're doing. Their colleagues probably do as well, but the computer doesn't. So if you have a look down here, okay, for example, I've got color-coded, yellow is meditation and blue is no meditation. But when I read that in, it's only going to be numbers. They're not going to know whether it was yellow or blue. So we need another variable in here that's probably 1 for meditation, 0 for not, for example. Up here, if we read this into Stata, it would take that top line as being the variable name. So all of this would just be considered data points, and so every single one of those variables would be set up as a string, and start again. What else have we got? What's wrong with this gender column here?
Always expressing it, it's not encoded form.
Yep, it's all over the shop. So even if we read in this, you can use functions in the stats package to recode it. Very easy to do if it's all female and male exactly the same way. Otherwise, you're going to have to tell it that M and little m and male with a couple of spaces at the beginning, and males with capital R are all 0. It takes a lot longer, and you'll miss one, and then you'll have to go back and do it again, and it's just makes your life hard. And we're not joking, are we, Paula, about how much time this takes? I think my record, I had some data come in from a hospital system, and their dates were entered into that, and it took me 8 hours to work out what was going on with these dates. Half of them were in American format, half of them were in Australian format. Some of them had milliseconds attached, other ones didn't. So everything, nothing was lining up. All we needed to do was to make sure that it had been entered all in one format, and everything would have been fine. So, speaking from experience, yeah, it was within my first year of working here. Now I'm a bit meaner. But can you fix that? We've got means down here. So your stats package is going to include this in any computation to do with temperature, for example. There's missing data over here. Is that missing because I know Paula, if there's missing data, she leaves it blank. She sets it as miss. I like to put codes in. It's it's not a one way or another situation. It just depends on the way you like to do it.
It's like the dots.
No, because that's text.
That's
Yeah.
right.
Mm-hmm.
Because in SPSS, it looks like there's a dot for missing data points.
Yeah.
It's not actually a dot, it's just to show you that cell is empty. So it's a visual. So people who know that, then put dots in itself. Like, no.
Yeah, and you read it in and it thinks it's all text.
Yeah. So either blank or a code.
Yeah, numeric code. Yeah, not applicable.
Yeah.
What else did we have? I've got some answers on. The variable names. Can anyone see any issues with the way these variable names are written?
Yeah, temperatures are different. So the first temperature is.
Yeah. I've used test 1 at the top here, and then the names where I've included the test time along here as part of that variable. This sort of data is the sort of data that you may want to restructure because it's a pre-post measurement. If you were going to run a mixed model, for example, you would need to make it long. And to do that, I need to say, well, this part of the variable matches up with this part of the variable, so you put them all in the same column, and this bit is what tells me which time it was to get the computer to do all that restructuring for you. But when it doesn't match up, it doesn't know what it's doing, and you end up with variables all over the place and lots of missing bits, and it's just a nightmare to fix up. So just be consistent with whatever variable name you choose.
Well, those temperature decimal points, you've got obviously sort of implies different level of accuracy.
Yeah.
Is that a problem, or would you just reformat it to say 1 decimal point? You're assuming that 37 might be 0.
Yeah, I'd have a look at the format that was in, because there's always the potential that this was just set to show 0 decimal places accidentally, and there would actually be some decimal places you can't see.
Yeah.
Once you read it into SPSS or Stata, it should show you everything that's there. I guess one thing to do there is if you expect decimal points to be entered, you could format that cell to make sure it's always got that 0.1. Yeah, it does look. I suspect what's happened is I've wrong way. Put 0 and it's got rid of it. Sometimes Excel does that. I don't know why. Yeah, so I think that's pretty much it. Yeah, the variable names. Some of them started with a number. The variable names are inconsistent. Problems with gender. Row means, get rid of them. Color coding. This is missing values, and there wasn't actually any dictionary included in that one as well. That's just a trick one. But other than that, as I said, it's fairly basic stuff. But if you start that way, you're going to save yourself hours and hours of work. And I think we all want that. We've all got too much work. Are there any questions or queries or anything specific?
I was going to ask if you had a data set like that one, that example one, and then it was very long, and you suddenly thought, it would be great to have the data validation stuff set up. Can you retrospectively put some things in?
You can do checks on the data, so you could set up like an if statement to make sure that all those data points were less than a certain value or greater than between certain numbers, something like that. I'm not sure whether you can go back onto an entered cell and check it and put it over the top. I haven't actually tried. That's a good question. It might be worth checking. If I had a long data set like that and I wasn't sure about it, probably what I'd do is fix up the variable labels, get rid of the means, and probably put in a variable, I'd say, for the condition that the individuals were in, then I'd read it into the stats package, and I'd do all my checking and summarising that, and then send it off to the owner of the data and say, look, these are the things you need to fix. Yeah, that's what I would probably do. I don't like checking data in Excel. I'm not as confident with it as I am with Stata, for example, but the big advantage Data has is I can do it all in a do file, which is essentially like a syntax file in SPSS. I can rerun it on exactly the same variables and replicate to what I've done in the past. Whereas with Excel, you could easily not include one cell and the answer would be quite different. I can't go back and check that as easily. So, but I think that's a lot to do with experience with having done it. If you, I think I try to. I think that data entry and data analysis needs to be considered the same way as any kind of data collection. To be done in a way that is reproducible and transparent. And for me, using the stats package and the syntax sort of programming options is much more transparent and much more reproducible than using Excel. But there are probably some users out there who could use Excel just as well. It's just not what I'm comfortable with. But anyone who's doing their own analysis really needs to get confident with using a stats package, so it's probably worth you doing it. And if you're not doing your own analysis, then any statistician who you go and see or biostatistician, the first thing they'll do is go through and check your data to make sure it's clean. If they don't, you probably want to ask me that, because that is, otherwise you put rubbish in, you get rubbish out, right? And you can't actually interpret anything there. And the last thing you want to do is actually submit the paper and then realise there were mistakes. So that's happened before. So it's just about being logical, consistent, transparent, knowing our own human faults. We are going to make mistakes, that's okay, but let's put things in place to reduce that number and then check it once it's in your thing. So you've got multiple checks. Chances are then your data set will be as clean as it possibly can be.
With the coding of the data, so with like the gender being 0 and 1, is there a way to get it so that when you export from Excel into, I'm using SPSS, that it automatically knows your codes?
Not that I know of. So you still have to, you can do it in a syntax. Do you use syntax files? So you can set it up in your syntax file. But no, I don't know of any way. Wouldn't that be nice? It's the same in Stata. It'll read it in as 0s and 1s, and then I've got to set the codes up in the syntax file. That would be awesome. Maybe we should write to the stats packages and say, could you collaborate with Excel, please?
That was really useful. I was saying before, I'm about to teach first year science students, semester 1, first year, basics. You want to kind of catch them really early and put into their mind these sorts of things. And so,
great.
All everything you're talking about, that makes sense. That makes sense. Oh, yeah, I do that. I didn't realise I do that, but I do that. But just having that overview is really good.
Because I've had some beautiful students, really top-notch, intelligent, honest students, and they come in, they go, I've got my data ready, and it is fantastic the way it's set out, but it's not usable at all, and they have to go and read it a lot. And that, you've tested 50 people, and over multiple testing sessions, and you've read in data from equipment, you've got questionnaire data, and going, well, I can't use it, you're going to have to do it again. And it was just, I think in some ways they're probably thinking too hard about it. But if we can avoid that from the beginning, so it is a very basic talk. It's not like, but it seems to be, well, from my experience working here 3 years-ish nearly, from my experience, this is probably the hardest bit, is making sure it reads in.
Yeah, I mean, I'm someone who probably doesn't set things up as they should be. So I know data sets where I think afterwards, why don't I do it like this? And I've also seen, I've got colleagues who publish papers and so on, they go, I'm just shocking at managing data and those sort of things. And I think sometimes it's just, you start off and sometimes you just follow your nose, and by the time you establish your practices, you realise it's just a bit eclectic and
and there's definitely room for movement within those sort of ideas. That's what works for me, and from what I've discussed with Paula and from what I've seen with other students and staff, that seems to work okay from what they taught me in my data management unit through my masters. That's all what seems to come through, but there's always going to be a little bit of room for individuality there, provided it is still clear, understandable, reduced risk of data entry error. and communicate to others. I think it's great.
7 unit that I ran.
Yeah.
A number of the science-based students who came through and then did honours and research projects, they used a lot of this that we covered in the unit and did it. And so they were in a really advanced stage. So those that end up following that pathway and get them early, I think it does stick and they do change their practice. There will always be those that don't.
Yes.
But I think the ones that are legitimately interested will actually apply them.
Yeah.
And there's more and more journals now that are actually looking for your data and your script files, and so they can try and reproduce what it is that you've analysed. So if you're not methodical in the way you set it up, that's almost impossible. And I've got data sets from other people and tried to reproduce what they've done, and it's completely opposite to what did you do? You know, it's not an uncommon scenario. And I think there's a new data management policy out through the university that I have to read.
Yes.
It's just come out. I have to get on top. Things like how you should store your data afterwards. You know, SPSS goes through a new version every year or two, and I've got PhD data. I can't actually read into SPSS now. So if you store it as a .csv, so CSV, comma, separated variable, so basically like an Excel file, that can be read into the next version quite easily, but it's not something I really knew about or thought of 15 years ago. So there's a lot more to it. That's just the entry. There's the data cleaning. There's the management process of it after you finish your study. There's the analysis management and using syntax files and do files and making sure that everything you do can be traceable and reproduced, which a lot of students don't do. We don't specifically teach them to do syntax files. Usually we say, here it is, it's available. Some of the postgrads we will, but a lot of the honours students don't. So there's still quite a lot of practical kind of stuff around this before you even get to, you know, what does p-value mean? A lot of practical learning.
Yeah.
That's what we're in the process of trying to set up modules kind of like this that would be very useful for students and staff who haven't had much experience at like small chunks of information. You know, this is data entry, and we're working on data cleaning one and the basics of stats theory. What is a statistic? Why do we do it? You know, this sort of thing, which often isn't covered. And I personally feel that if people had those gaps filled, there's going to be much more stable base to build upon, rather than coming to this level and saying, right, we're going to do a linear mixed model, and they don't even know what a t-test is yet. You know, that's an over-exaggeration, but I just sort of feel like there's a lot of gaps, not a strong structure. I don't know. So that's what we're working towards. So any feedback would be greatly appreciated. If there's something you do that I haven't included, that would be wonderful. Any particular topics or areas you think you could benefit from, I'd love to hear about it.